star that could be shocking in our sky is this one, Betelgeuse. It's a red giant star. It's only 600 light years away. It's very unstable. It's about to explode.
When Betelgeuse dimmed dramatically in 2019, many thought the supergiant was reaching its final days.
We'll see a region of sky brighten for 14 days, until it's nearly as bright as a full moon.
Scientists waited, debated, and speculated. Now, in 2025, fresh discoveries reveal something even more startling. Betelgeuse isn't alone. Hidden in its glow lies a stellar companion, quietly circling, its fate bound to the same explosive end. The countdown to cosmic transformation has already begun.
Everything rushes into the middle. And that sets off the most dramatic explosion in the universe.
The dimming mystery of Betelgeuse. In 2019, one of the brightest and most famous stars in the night sky suddenly started acting strangely. Betelgeuse, the huge red supergiant in the Orion constellation, began to dim in a way no one had seen before. Astronomers around the world watched in surprise as its brightness dropped so much that some even wondered if the star was about to explode into a supernova.
I look up at Orion and I see Betelgeuse, and I'm like, explode!
This mysterious period became known as the Great Dimming. At first, no one knew why it was happening. Some thought the star was cooling down inside, while others believed something outside was blocking its light. For months, theories flew around. Then, in 2025, clearer observations finally gave the answer. Betelgeuse itself had thrown out a giant cloud of dust. This dust drifted in front of the star, temporarily hiding its light from Earth. The discovery showed just how unpredictable Betelgeuse can be. The star is about 10 million years old, incredibly massive, and nearly 700 times the size of our Sun. Because of its size, it burns through its fuel very quickly, which makes it unstable. Every so often, it pushes material off its plasma mountains in violent bursts, almost like a stellar hiccup. That's exactly what created the dust cloud that caused the Great Dimming. While the mystery was solved, the event reminded scientists how difficult it is to study such massive stars. Betelgeuse's changes are driven by pulsations, natural swelling and shrinking, and by the material it constantly sheds into space. These behaviors keep astronomers guessing and glued to their telescopes. The Great Dimming also led to big advances in technology. To study the event more closely, astronomers used improved imaging methods and sharper observations. Their work didn't just solve the puzzle, but also opened doors to new discoveries. Saworha, the stellar companion. In 2025, astronomers finally confirmed something they had long suspected. Betelgeuse, the massive red supergiant in Orion, isn't alone. Using the Gemini North Telescope's powerful speckle imaging, they managed to directly spot a faint companion star. This companion has been proposed to carry the name Saworha, which beautifully translates to her bracelet in Arabic. Finding Saworha wasn't easy. Betelgeuse is so bright and overwhelming that anything nearby gets drowned out by its glow. But with advanced imaging, astronomers managed to separate Saworha's light from the glare of its fiery neighbor. What they found was fascinating. Saworha is a hot blue-white star, about 1.5 times the mass of our Sun. It orbits Betelgeuse at a distance roughly 4 times greater than Earth's distance from the Sun, well within the giant's extended puffy atmosphere. What makes this discovery even more intriguing is the contrast between the two stars. Betelgeuse is nearing the end of its life, unstable and massive, while Saworha is still in a youthful stage. In fact, it hasn't even begun the process of hydrogen fusion in its core, meaning it's still in what astronomers call a pre-main sequence phase. So while Betelgeuse is burning out, Saworha hasn't truly started shining at full strength yet. The discovery also helps explain some mysteries about Betelgeuse's odd behavior. For years, scientists suspected a hidden companion might be affecting its outer layers, causing some of the star's periodic dimming. Now, with Saworha confirmed, those theories make much more sense. Still, Saworha lives in a dangerous neighborhood. It is 6 magnitudes dimmer than Betelgeuse, making it fragile in comparison, and its position so close to the supergiant puts it at great risk. Eventually, it could be pulled in and consumed by Betelgeuse's gravity. Or worse, it might be torn apart when Betelgeuse ends its life in a spectacular supernova. Speckle imaging. What surprises many people is not just the discovery of Betelgeuse's companion star, Saworha, but the fact that scientists didn't see it for so long. How could a star orbiting one of the brightest objects in the sky go unnoticed? The answer lies in both the challenge and the technology needed to overcome it. Betelgeuse is a massive red supergiant that shines so brightly it overwhelms almost everything nearby. Its sheer size and brilliance created a kind of cosmic spotlight, drowning out the much fainter glow of its companion. For decades, astronomers suspected a hidden star might be there, but the evidence was always too fuzzy to confirm. The breakthrough came with speckle imaging, a clever technique that uses thousands of super-short exposures to freeze the effects of Earth's turbulent atmosphere. Normally, the air above us makes stars twinkle, blurring their true appearance. But by taking rapid snapshots and stacking them together, speckle imaging produces sharp, high-resolution images that cut through the blur. Using the Gemini North Telescope's 8.1-meter mirror in Hawaii, NASA scientist Steve Howell and his team applied this method with the Aloe Peak Speckle Imager. For the first time, they were able to separate Saworha's faint blue-white streak from the fiery orange glare of Betelgeuse. It was like finally spotting a firefly hovering next to a floodlight. Not only did this confirm Saworha's existence, but the team also gathered details about its orbit and nature. This was the first direct observation, and it gave astronomers the solid proof they had been chasing for years. The success of this discovery highlights just how transformative speckle imaging has become. Once developed to sharpen views of stars blurred by the atmosphere, it's now unlocking hidden details in crowded star clusters, revealing exoplanets, and helping study binary systems like this one. The binary dance of two stars. Have you ever wondered what happens when two very different stars end up locked together in space? That's exactly the case with Betelgeuse and its newly confirmed companion, Saworha. Together, they form a rare binary system that has scientists both excited and puzzled. Betelgeuse is a massive red supergiant nearing the end of its life, while Saworha is still young and hasn't even begun burning hydrogen in its core. What makes things even more fascinating is their closeness. Saworha orbits inside Betelgeuse's extended atmosphere, a region filled with hot gas and plasma, at a distance about 4 times greater than Earth is from the Sun. That's dangerously close when your neighbor is a dying star hundreds of times bigger than the Sun. This closeness means their fates are tied together. Betelgeuse's constant pulsations and sheer size could disturb Saworha's orbit, possibly even contributing to Betelgeuse's mysterious dimming events. Some astronomers also believe the smaller star might trigger violent mass ejections from Betelgeuse, pulling material out of its unstable outer layers. And the future? It doesn't look peaceful. Within the next 10,000 years, Betelgeuse's gravity might drag Saworha in completely, leading to a fiery merger. If that doesn't happen, there's the other possibility. When Betelgeuse eventually explodes as a supernova, Saworha could be flung out of the system entirely, or have its orbit thrown into chaos. Either way, Saworha's fate is tied to Betelgeuse's dramatic end. For astronomers, this system is a rare chance to study stellar evolution in real time. Binary systems are common, but finding one where the stars are at such different life stages is unusual. On one side, we have a dying giant. On the other, a star that's just beginning. Watching how they influence each other could help refine models of how stars live and die, especially in extreme environments like this. The story isn't over either. In November 2027, Saworha will reach its farthest point from Betelgeuse, giving scientists their best opportunity yet to study the system in detail, but that doesn't mean there are no theories yet. Saworha's mysterious appetite. This little star may not just be hiding, it might be feeding. Some scientists suggest that Saworha could be a kind of stellar cannibal, quietly gorging on stray cosmic objects while orbiting inside the chaos of Betelgeuse's extended atmosphere. Its blue-white light was so faint and so often drowned out by Betelgeuse's brilliance that for years no one realized what it was really up to. Unlike calm, steady stars, Saworha might have an appetite that sparks unpredictable bursts of X-rays, flashes too subtle for older telescopes to spot through Betelgeuse's overwhelming glow. Imagine it chewing through a swarm of comets, or even tearing apart a small protostar. Those cosmic snacks could dim its shine, leaving astronomers puzzled. In many binary star systems, companions trade mass. But Saworha seems to go further, pulling in debris from the surrounding Orion molecular cloud, where both stars were born. Each meal could unleash messy plasma jets, scattering Saworha's light like a candle flickering in the wind. For years, astronomers may have mistaken those faint bursts for Betelgeuse's own natural pulses, never realizing a second star was hiding in plain sight. So what exactly is Saworha eating? It might be swallowing clumps of gas, or maybe even the remains of a dwarf star shredded by tidal forces. Recent data has shown faint X-ray spikes, which hint at high-energy collisions, mini explosions that could even stir up Betelgeuse's magnetic field. These little flares might be the fingerprints of its violent diet. The real breakthrough may come in 2027, when powerful new X-ray telescopes take a closer look. Perhaps the dust is just a glowing ring of devoured matter. For now, the questions pile up. Is Saworha still feeding, or has it paused to digest? Its orbit takes it dangerously close to Betelgeuse's turbulent atmosphere. Saworha's black hole beginnings. What if a small, faint star could transform into one of the most mysterious objects in the universe, a black hole? That's the possibility scientists are now considering for Saworha, the blue-white companion star to Betelgeuse. Hidden until 2025, this star may have been feeding all along, pulling in stray matter and growing denser with every bite. Its light, already dim compared to Betelgeuse, could have been further muted by the chaotic swirl of debris it has consumed. So what exactly might Saworha be eating? Astronomers suggest it could be devouring gas clouds, cosmic dust, or even the remains of a shredded star. In many binary systems, mass-hungry companions grow this way, snatching whatever floats too close. And Saworha's tight orbit around Betelgeuse makes it a perfect trap. Each chunk of matter it swallows could bring it one step closer to a black hole's birth. If that happens, the effects could be dramatic. A collapse into a stellar mass black hole would release bursts of energy, perhaps faint glimmers of Hawking radiation, signals future observatories might detect. Saworha's growing gravity could also tug on Betelgeuse's outer layers, twisting its atmosphere into strange arcs. Some scientists even think recent odd magnetic flares around Betelgeuse might be early signs of this process. But the big question remains, where is the tipping point? How much more mass does Saworha need before gravity crushes its core completely? A planned X-ray survey in 2027 could help answer that. If astronomers spot an accretion disk, a glowing ring of doomed matter spiraling into Saworha, that would be the smoking gun for its transformation. And then there's the future of the whole system. If Saworha collapses first, it could outlive Betelgeuse's supernova, circling the ruins of its once massive partner like a silent predator. On the other hand, its gravitational pull might destabilize Betelgeuse, speeding up the giant's violent end. Either way, this cosmic duo isn't done surprising us. Extraterrestrial blurring. What if Saworha's strange, faint glow isn't just a trick of starlight, but something far more mysterious, like alien technology? Betelgeuse's hidden companion star, only detected in 2025, might not simply be faint or blocked by dust. Some scientists have begun to wonder if its blurred appearance could be the result of an extraterrestrial megastructure, maybe even a Dyson swarm or a cloaking device, built by an advanced civilization. Such a structure could scatter Saworha's light, making it nearly vanish beside Betelgeuse's blazing glow. Rumors suggest a web of giant solar panels or collectors circling Saworha, harvesting its energy to power a far-off starship colony. If these structures were built from ultralight, futuristic materials, they could bend and refract Saworha's light, creating shimmering distortions. Older telescopes, before 2025, wouldn't have been sharp enough to notice, so any unusual flicker may have been written off as Betelgeuse's natural brightness. Researchers have often speculated that megastructures could explain odd star flickers. Could Saworha be another piece of that puzzle? Adding to the mystery, recent radio scans from the Betelgeuse region have picked up faint, irregular signals that don't look like normal stellar noise. Could this be technology at work? If so, maybe these alien structures are more than just energy collectors. They might also manipulate Saworha's magnetic field, producing artificial flares that look like natural star pulses. Some theories even suggest the structures could repair themselves, absorbing cosmic dust to keep the cloak intact. But the big question is, why hide Saworha at all? One idea is that aliens might be using it as a disguised observatory, watching Betelgeuse as it heads toward its dramatic supernova stage. When a giant dies, who survives? Betelgeuse is a star that has always fascinated astronomers, but its story is far from over. This red supergiant, sitting about 640 light-years away, is nearing the end of its life.
Because it's only 600 light-years
God,
away. So that would be one of the most spectacular astronomical events ever. Might be in our lifetime.
At some point in the future, it will explode in a supernova so bright it could outshine entire galaxies. But what makes this tale even more intriguing is the presence of its close companion, Saworha. Saworha orbits dangerously near Betelgeuse, and that closeness makes its fate deeply tied to the giant star's final moments. If Betelgeuse explodes before pulling Saworha inward, the blast could send shock waves powerful enough to either incinerate Saworha or fling it out into the darkness of interstellar space. Imagine a whole world suddenly set adrift between the stars. There's another possibility too. Betelgeuse's massive gravity could pull Saworha closer before the explosion even happens. If that occurs, Saworha may get swallowed up, releasing a sudden burst of energy that would make the final collapse even more dramatic. Either way, Saworha is walking a cosmic tightrope, and its end will be spectacular. For scientists, this strange binary system is more than just a curiosity. It's a natural laboratory. Most supernova studies focus on single stars, but with Saworha in the mix, astronomers have a rare chance to see how a nearby companion might change the outcome. Could Saworha alter the shape of the debris field? Could it change the way the light from the supernova fades over time? These are questions that can only be answered when Betelgeuse finally reaches its breaking point. Of course, the big unknown here is timing. Predicting exactly when a star like Betelgeuse will explode is nearly impossible. It has already burned through much of its nuclear fuel, and its huge size and relatively young age, just 10 million years, tell us it's nearing the end. Still, whether the end comes tomorrow, in 1,000 years, or much later, is something even the best models can't pin down. So, what does all this mean for us here on Earth? Cosmic light show without the danger? When a massive star nears the end of its life, things get messy. Sometimes it's fusing hydrogen, sometimes helium. Sometimes it shuts down for a while, and then it suddenly starts burning again. The outer layers drift so far from the hot core that they almost seem to do their own thing. In short, it's chaos. Betelgeuse, the famous red supergiant in Orion, is in this unpredictable stage. Based on its mass, how fast it spins, the stars it was born with, and even the metals we see in its atmosphere, astronomers estimate it has maybe a few 100,000 years left before it explodes as a supernova. But here's the catch. It could also happen much sooner. Because Betelgeuse is about 500 light-years away, the light we see is already centuries old. If it exploded 100 years ago, we wouldn't know yet. For all we can tell, Betelgeuse may already be gone. Whenever it does blow, the show will be unforgettable. Supernovae are so powerful that they can outshine entire galaxies of billions of stars. At Betelgeuse's distance, the explosion will be visible during the day, brighter than any planet, and nearly as dazzling as the full moon. Imagine stepping outside at midnight and being able to read a book by its light alone. But unlike the full moon's wide disk, Betelgeuse will still look like a tiny dot. That means staring directly at it might even be uncomfortable. The supernova will blaze for several months before slowly fading away, as all supernovae do. The good news? As spectacular as it will be, it won't pose any danger to us. That's thanks to something called the inverse square law. Light and radiation spread out as they travel. The farther you are, the weaker the energy becomes. Double the distance, and you only get a quarter of the intensity. At 10 times the distance, it drops to 1/100th. Think of standing near a campfire. One step too close and you're overheating. One step back, and suddenly, you're chilly. That same rule applies to supernovae, except we're so far away that we're safe. So when Betelgeuse does finally go supernova, Earth won't be in danger. It will simply turn from a familiar red dot in Orion into one of the brightest sights in the sky, a once-in-a-lifetime cosmic light show. Spotting Betelgeuse in the night sky. When you look up at the night sky, few constellations are as easy to recognize as Orion, the hunter. And sitting right on his left shoulder is Betelgeuse, one of the brightest and most famous stars in the heavens. While it's the second brightest star in Orion, it still stands out with its reddish glow, contrasting beautifully with Rigel, the constellation's brightest star, which shines a bluish light from Orion's right foot. Finding Betelgeuse isn't too tricky once you know where to look. Start with Orion's belt, that neat line of 3 stars you can spot almost instantly. Just above the first star in the belt, Alnitak, you'll see Betelgeuse glowing in all its glory. On the opposite side, below Mintaka, you'll find Rigel. The layout makes Orion one of the most striking constellations to trace with the naked eye, even for beginners. But Betelgeuse doesn't shine alone. It's also part of another sky pattern called the Winter Triangle, sometimes referred to as the Great Southern Triangle. This asterism connects Betelgeuse with 2 other dazzling stars, Sirius, the brightest star in the night sky, and Procyon. Together, they form a vivid triangle that sits inside an even larger pattern known as the Winter Hexagon. These interlocking shapes give stargazers more than one way to find their bearings in the chilly night skies. If you want to spot Betelgeuse yourself, the best time is between September and March. During this period, it rises in the evening, starting around sunset, and makes its way across the sky. December is often considered the perfect month for viewing since Orion dominates the night sky during winter. Your location on Earth also matters. In the northern hemisphere, you'll want to look toward the southwest to catch Betelgeuse, while in the southern hemisphere, it will appear in the northwest. The star is visible from most places around the world, stretching between 85 degrees north and 75 degrees south latitude. That means unless you're extremely close to the poles, you'll have a good chance of seeing it. So next time you find yourself under a clear night sky, look for Orion, trace his belt, and then lift your eyes to his shoulder. There you'll find Betelgeuse, bright red and impossible to miss. We hope you enjoyed this video. Stay tuned for more mind-boggling stories.